Welcome back. So we have been dealing with different types of prompts, right? And we are at a stage where we're almost nearing to the end of the prompt, and as we started exploring each prompt, as we are nearing to the end of it, the prompts are becoming more and more important, and now we know how do we organize the day-to-day problems into a prompt. That's the important takeaway of this particular video series. It's not the knowledge of the prompt, it's more of how do you make yourself a prompt which will help you in the troubleshooting or your day-to-day process, right? One of such important prompts or ideas is self-consistency. Repeatedly prompts at high temperature and selects the most consistent response. The application is generate multiple answers and choose the one that aligns more frequently. This is more of a reasoning model sort of thing. Now, if we go for an example here, right? So we'll say, analyze the cause of intermittent packet loss between router A and router B. Consider physical connections, network configurations, and external factors. Again, it comes back to the COT, chain of thought, where it says let's think step by step, right? And it goes ahead and it tries to give different types of outputs, and it gives a final answer and stuff. A good answer or a good example here is it gives us various steps and a final answer. The most frequent reasoning path points to the issues with physical connections. This is selected as the most consistent answer. So it tries to reason through at least 3 different or 4 different types of responses, and then it comes back. So the reasoning models are playing their part here. Bad example, a network engineer is diagnosing intermittent packet loss between 2 routers. Diagnose the packet loss issue between router and router. There is no step-by-step, there is no reasoning, nothing of the mention here, so it gives us a very generic answer. Now, let's try to see this one in Gemini. Okay. Again, we'll create a prompt, this is something that I use personally. This is to troubleshoot a high CPU on a Juniper router. So don't worry, I'll share the prompt. So let's create a gem, right? So I'll say high CPU on Juniper router. Troubleshooting. These are the instructions, right? So let's start a chat. So generally, if you have access to the router and if you have enough tooling, the agent will be able to figure out most of the issues. But let's pretend that router R01 has 99% CPU usage, something. So it gives initial observation, potential causes. Now it's brainstorming as per our prompt. So it says unexpected surge in traffic volume or rate on one or more interfaces could be overwhelming the router processing capabilities. Okay. Resource intensive protocol features. Certain protocols or features when under heavy load can consume significant load. Control plane overload, security threat, which includes DDoS, software anomaly, hardware issue. So let's start by checking the interface statistics. Could you please provide the output of the command? And from here it then goes step by step. So you then start building on something like that. So that is why this will become a second engineer to you to help you analyze a particular situation. It will It need not be an agent logging into the router. You can always like have it locally on your computer, if the data policies allowed by the organization. You can always have an API call within your organization's LLM, or like if you are in a lab environment, you can always like do an API call to OpenAI or Gemini, for example, right? So we'll then explore something called a generate knowledge aspect of an LLM, which is quite interesting. So I'll see you in that video.